Hey guys, hang on a sec. Let me switch on my video, and you should all feel free to do the same. All right. Actually, check it out. It's exactly the same T-shirt, same glasses, same place. Let me go back to video. I tried this yesterday, but I didn't get the framing quite right. And I also have to look down, I think, a little bit. Okay. I don't know. Is this the same pose? I got to watch the video because I'm looking down. I can't see the screen, so I don't know what I look like on screen. So I got to watch the video to see if it's exactly the same. It's like 2 years ago. That photo was from 2 years ago. Exact same T-shirt and glasses. So kind of cool. That'd be fun, isn't it? Because I saw a video once of some guy out there in a company, and it was a YouTube video, and he fooled his colleagues in the company into thinking that he was actually at work by just having a static photo, and nobody could tell the difference because everybody else in the meeting was basically just not saying anything. They were just like this, and so that's why it's very important in our class meetings to keep talking, and at least your lips should be moving. Otherwise, I have no idea of telling if that's a static photo or you're really there, because I remember Eric Lund, last class or the one before, he was there, and I was thinking that he was there with a peace sign and all, and I thought that he was there in class and I saw every time I look at him, he's always making a peace sign. So I thought, wow, this guy must be really a hippie, he's always saying a peace that, but turns out it was a photo of him doing that, and I couldn't tell. And so, yeah, it's very important that you at least keep smiling, like Thomas or Samir. Okay, so I know that you're not a photo. Great. Okay, now we're all here. Yes, please do switch on your cameras, because as you can see from the last video, it's much better with all of you guys participating. And I also see that a lot of you have taken the trouble to convert your names into hex and so on. Samir, especially, dived quite deep into it, and so I like that very much. So thank you. And obviously, these will all count for credit. If you really do want some extra credit reflected right there, let me know. I have a column in my Canvas thing to have random extra credit. You won't see it, but it's in there. So maybe it's not, maybe you can see it, I don't know. But definitely, people are taking these initiatives to get these points added up here and there, and that will actually make a difference if you're gunning for points and all. Okay, but even if you're not gunning for points, you should do that because it's fun, and that's the whole point. It's fun to do these things. Okay, all right. So today we will start coding. Okay, so we'll start coding, and everybody will get a chance. But every class, usually 1 or 2 people take the screen. So what we'll do today, today's plan, I'm thinking, is that we'll just code a very, very simple project. Okay, very simple, not project, it was a very simple program. One program, probably not more than 10 or 15 lines of code. Anybody can code it, right? And I mean, if you got someone in elementary school and got them to code, they'll be able to do this too, meaning that this is the absolute entry point. You don't have to know any computer science or C++ in order to get this done, because we'll be walking you through every single step of the way, where to put braces, where to put spaces, and also after we do this and run it, we'll also take a look at the program and look at the different places in the program and say, hey, what is that funny character hash sign at the top? What does that mean? What do these tokens mean? Answer all those questions. Okay, I'll answer all those questions, make sure that you're completely solid on all those fundamentals before we start modifying that program. Right, so we have something. It's always important to start with something that works. And one of the problems I've noticed with some programmers is that they're working on a big issue, big product, a big project, but they don't test it until they get to the some critically big size, and that is actually a very, very bad practice. It will basically decelerate your progress when your colleagues are just zipping past in a professional setting. And it's not because they're more intelligent or more capable than you, it's just because they picked up a very good habit early on. That, many teachers don't even seem to teach early programmers. It is one of the most important habits to pick up, and a lot of student programmers ignore it because they say, I want to get this done. So I want to get through as fast as possible and test the final thing. If it's not working, I'll look up online and fill in the bits and somehow get it to work and go on to the next step. That is absolutely no use. You may as well not even be doing this course. Okay, just give me $150 and I'll put it in my pocket and you can go away. All right. So this course gives you absolutely nothing if you do that. So the idea is that computer science, the process of learning computer science is itself a computer science task. What do I mean by that? So computer science is the idea behind computer science is that there are problems in the real world that cannot be solved in one shot like that, bang. Yes, because some of you who are probably doing mathematics, you'll be able to relate to this. In math, you can come up with a proof. You can see a theorem and you can prove it, and it's analytical, meaning bam, you can go from here to there. You just see steps. But in computer science, there are problems that you cannot solve in one step like that analytically. However, you can prove that you can prove mathematically that even though I can't solve that problem in one step, I can solve it in 5,000 steps. All I need to do is just take one step at a time. Now, so that is the computer science way of looking at problems. So, and there are you'll find out, right? There are lots of problems in the world which actually fall into that bucket. Lots. Huge number of problems, judging from the fact that there are computers almost everywhere, huge number of problems that have incremental solutions. Now, people who are not looking for incremental solutions, who are looking for one-shot solutions, will never find those. Yes, because they say, well, you know what, it's there, but I need to get to it after 5,000 steps, so I won't look at it. Let me see if you can find an instantaneous solution. So in a world where people are looking for instant gratification, saying, I want to eat that candy right now. I can't wait for 5 days so that, it looks better, or things like that. They'll never find it. They'll never find the deep pleasure of these things because they're always going for instant, bam, bam, bam. And so computer science is basically saying a reality check. This is a reality check, right? You're in a fictitious world where everything comes to you like that. You want an iPad and your mom or dad says, oh, here you go, there you go. All right. But no, that's not the real world. If you didn't have your mom and dad, if you didn't have all these well-wishers after you, and you wanted something, you're not going to get it like that, bam, right? You're going to have to say, well, you know what, I want a good meal at the end of the day, so let me first go and get some bread, let me go and get some rice, let me go some salt, vegetables, and all these things. I got to make these things. It's going to take me 2 hours, but at the end, I'll have a really good meal. Yes. Whereas when we're kids, we want a good meal. We just go and say, hey, mom, I'm hungry. And she'll just give you something, right? And we say, okay, I'm not hungry anymore. And and many people are just spoiled, I think, it's not spoiled in a bad way, but they don't get to know the pleasure of gratification after a delay. Meaning, well, you know what, that is what it looks like. And that's why it's so valuable. That is why an iPad is valuable, because it actually cost $250, which took me 5 weeks of washing cars to get, right? So you don't get that feeling when you get things instantaneously. And when you don't get that feeling after having worked for a certain amount of time to get it, the pleasure you get from that also dissolves as quickly as you get it. But if you work for a little while in order to get a pleasure, that pleasure also lasts for that long. At least, it's not instantaneous anymore. So, and that is a different kind of pleasure. It's not, because instantaneous is just touches you and goes, touches you and goes. And when it touches you and goes, you don't feel it as much. But when it sticks and lingers, and you feel, wow, okay, you know what, I've got the deep thing now. So that is the computer science way of looking at it, saying that there are all these problems that you can solve just by incrementally approaching it. And so, and the reason it's important is because you can bring the same attitude to learning also. And learning also, a lot of people, as you may know, and from our own experience too, initially we think, this is instantaneous. I can learn. Okay, if I'm not able to learn it, I just have to figure out how to learn. No, it's sometimes you cannot learn that thing until you learn this thing, and this thing, and this thing. And, each one of those is contingent on the previous one. So you got to learn one step at a time. That is how the quests are set up, okay? The first quest, because people who say, I want to learn computer science, I want to go right to quest number Red 9 and finish it and say, I'm a master of computer science, they can't do it. You try it. Try to get the password from someone who's done it, Walter's here, he's done all of it, and go straight to question number 9 in red. You can't do it. It's actually impossible. However, if you started at blue and said, I'm going to do one step at a time, by the time you come to red quest 9, you'll be feeling a little bit, a little antsy because, everybody says it's a really hard quest, but you'll say, well, it's hard, but I know because I've done a lot of hard quests along the way. I can bet you will have done a lot of hard quests along the way, and I also conquered them, right? You would have not conquered in the bad way, but you would know how all of these work. And by the time you get to the hard one, you'll say, well, it's hard, but I've done a lot of hard stuff in my life. I know how to tackle this. It's just a matter of time. So I don't have to panic or give up, or, I don't have to gasp for breath. All I need to know is just it is hard, and I'm going to get to it in 5 days, not in 1 day. And when you know that you're going to get it in 5 days, you won't panic anymore. And panic, when you start panicking, and I think I actually made this point in a Reddit post, when you start panicking, you're basically screwed, okay? You're screwed as a programmer, you're screwed as an employee when you start panicking. So that's why when you hire newbies, and the first task they're presented with out of college or something, they panic, right? And they'll say, oh, I can't do it. And the next couple of weeks, they're probably wasted. They think they were looking at everybody and saying, okay, I've got to find a good day when I have to quit this company without being fired, okay? Because I'm going to get fired at this rate. And so when that happens, if many people just give into that and they say, well, I'm a loser, right? I'm not going to make it here. I'm going to find something that's easier for me to do in life. And that is a tragedy, because that is not the truth. The truth is that you can actually do it. The only thing is that you have to stop panicking. How do you stop panicking? Because when you're panicking, and this is my theory, unsubstantiated, untested theory, if any of you are majoring in psychology and things, you should probably test it out. And maybe that'll make for us a pet project in psychology. And by the way, I keep reminding, because people join late, please do switch on your cameras. It's a whole lot better that way, because I can also react better to when I look at your faces and all. Yeah, Cecilia, I can see your camera, but there's a whole lot of people in the lower band of my Zoom screen that haven't switched on their cameras. So please do go ahead and switch on your cameras if you're able to, right? You can occasionally you can have your camera off, that's okay. But typically you should have your camera on. So what was I saying before? You panic. So this is the theory, is that anytime we panic, we believe that our life, our future is at risk. Otherwise you're not going to panic. Panic is the result of a belief, an incorrect belief in most cases, that your life or your future is at risk. You're going to suffer, meaning that you're seeing intense suffering down the line. That's when panic sets in. Okay, all right. So I think if you're in agreement with that so far, the next thing that happens is that what happens? What is the natural reaction of any living organism when it sees panic down the line? When you're driving along on 101 or some highway and you see traffic jam out there, what are you going to do? Right? You're going to say, I'm not going to go down that route. I'm going to look for detours, right? You go to Google Maps or, you say, well, plot a detour. I'll go this way, that way, that way. You're going to be looking at a zillion different ways of getting past. Yes or no? Yeah. Okay. That means at that point, fortunately, if you have a nav system, you're safe because you can keep driving and the Google system will drive for you. It'll figure out alternative ways and say, oh, yeah, now turn left and right and so on and so forth. However, if you didn't have that, like in real life, you don't have a Google navigation system in your head saying, well, I've got a problem I can't solve. I'm in panic mode. I need to get out of here because if I'm on this path, I'm going to get roasted in 5 days or, 5 months or 5 years. If I have to get out of here. So now you don't have a system in your head, an AI system yet, right? Maybe, later on in life, we'll have a chip that's implanted that can actually process multiple data streams and say, well, you don't have to panic because there's a way out. Maybe that's possible in in later life, but you don't actually need that. The trick is, and the thing is, you don't have to get that implant if you just master this little habit and a little skill early on in your life, saying, well, I don't have to panic because when I panic, all that's happening in my head is that 99.99% of my brain CPU, there's a CPU in your head, okay, your brain, 99.99 is not focused on finding the solution. However, it's all focused on finding alternative routes out of here because I don't want to stay in this hellhole, right? I'm going to die if I'm here. I'm going to find a way out. So you're basically not looking at the problem at all. You're looking at ways to get out of the problem. And that is why those people don't succeed. And so the trick to succeeding is to first settle down, okay? Settle down. and take a break. Don't even think about the problem. If you're thinking about the problem, your engines are running. If you're thinking about the problem, engines are running. And if your engines are running, they're not going to cool down, right? So you need to first switch your car off and let the engine cool. And only when it cools, it's not going to be, pointing in all directions at the same time, right? The steering wheel, okay? It cools, it settles down. When it settles down, you'll have an opportunity to orient it in the right direction. And then you can start it slowly, right? Without panicking. And then, step by step, you can go in the right direction. And and that's why the computer science way of looking at life problems also helps, because all it says is that don't try to try to take, a giant leap from here to the moon on day one. Okay, so just draw back, cool down, and take one step at a time. Go from here to the corner of the street. Okay, and and then go to the next city, go to the next country, and take it one step at a time. Because once you master something, you can do the next thing without panic, because you know that the next thing can definitely be accomplished by just doing the same thing that you already know to work 100% of the time repeatedly, right? I know this works 100% of the time, so I just need to repeat it 500 times so I get to the next step, and the next step again after that. It's the same, and everything will get faster and faster because you're doing it repeatedly. And that way you can solve any problem in life, right? Other than natural catastrophes and, things that happen, which you have absolutely no control over. Yeah, well, those things we just have to accept. But most of the time, I find that people are sad and disappointed and unhappy because they're not able to solve problems, but they're actually able to. They think they can solve problems that they can solve. And they cannot solve this problem only because they're not looking at the problem. They're looking elsewhere. Obviously not going to solve the problem. If you look at the problem, you're going to solve it. Any intelligent human, and which you are, everybody is an intelligent human, they can solve problems. And the only reason they're not able to solve problems is they're not trying to solve the problem. Okay, so the trick in solving any problem in computer science and life, I think, is basically just to draw back, cool down, and look at the problem. Okay, don't look at all these extraneous factors. And right, so when something's solved, you need to fix. I have to fix that. And I talk to other people, people I've helped in the past, and say, why aren't you not focusing on this problem? Why are you looking at, instead of solving this problem, why are you concerned about what that person is going to think of your approach to solving that problem? Why do you care a shit whether that person thinks your approach to solving this problem is inefficient because you're not clever, right? If you were as clever as me, you would have used a better approach to solve the problem. Who cares a shit about that? Right? So the idea is basically saying, well, I don't care about other people, what other people think of me, because my basic desire here is to solve the problem and move on. And a lot of people spend a huge amount of time. When I say panic, 99%, right? Out in the real world, lots of people spending huge amounts of their mental cycles. That's why, when people say you only use 10% of your brain and 90% of your brain is not used. And that is actually, I think that's 100% true. Because it's not like your 90% of your brain is unused, okay? Your whole brain is used all the time, but 90% of your brain is being used to solve useless, shitty problems, right? And that is why people are not succeeding in solving these problems and say, that person is like 10 times better than me. No, that person is basically just using 10 times more of their brain. And whereas 90%, you're using 90% of your brain to handle situations fictitious situations where you can look better in someone else's eyes, looking for validation from outside, right? That is what 90% of most people's brains are focused for. And no, that is useless. All of that will just evaporate. It'll evaporate because that is not real. What people, when you think, this is what other people think of me, at the end of the day, when you're on your deathbed, you will forget all of that. That doesn't matter at all. So all of that is fictitious, of fiction. It's out there, illusory. So why do you want to fight for an illusory goal that is not, or work towards something that is eventually just going to evaporate? So the only thing that is not going to evaporate is what you learn, your skill that will be with you until your very last breath. So that is the only thing you should focus on. And that way you'll say 100% of my cycles, I'll actually use all of that to solve my real problem. Okay, I'm not going to be concerned about what other people think of me. I'm not going to be I'm not going to concern myself even with what my professors think of me or the grade I'm going to get. Right. So what do I care what Anand thinks if I post a really stupid question on Reddit? Okay, in one sense you got to care because it's important that I know because I'm actually scanning these Reddit forums and everywhere, all of these places which I have visibility that you are able to talk publicly. You know, if you're talking on Canvas and you say absolutely stupid things that are going to tank your future, I don't care, okay? Because nobody's going to see that. But if you say something that could damage your future on Reddit, right? Saying, you know, C++ programs, everybody should not program in C++. This is a horrible language, okay? You'll never get hired by a company that uses C++. And every single big company out there is using C++, right? So if you say something stupid like that, I'll go and delete it. Not because I'm going to, you know, rap you on your knuckles, but I'm saying, don't do that because 5 years from now, you're going to wish that you didn't make that post. Because, you know, you're going to be applying to a job at Microsoft or somewhere. And now you made a post saying Microsoft is a shitty company because it released that IDE that has this feature, right? But 5 years later, you may realize that, well, you know what, that was actually a fantastic feature. I wasn't able to make use of it because I wasn't an expert programmer at that time. And instead of saying that I don't know how to use that feature, I complain, saying that Microsoft is a shitty company. Right? And you'll regret that 5 years later and saying, well, you know, that is why I didn't get a job when I interviewed at Microsoft. Even though I was good, they found stuff about me when I was bitching about Microsoft and there was no indication or evidence that I actually changed my mind and said, wow, you know what, I found that feature was really good. And so those are the things I look for and say, if there's something that's, you know, likely to be damaging to the future, I will delete it. So please, that's why it's important to, and also I made this point to CS2C and 2B, you got to start building up your portfolio right away. Maybe I said this to you too, right? Start right now and start building up a portfolio of online contributions, which you will also have my help for, because I will actually tell you and delete posts, right? Which could be bad on your portfolio. You know, if you're an artist, and you go to get employed, you're going to take a folder, a big folder, right? And say, this is my portfolio. Look at all of these things. But if you had an art teacher in school, right, who guided you through these things, who helped you put that portfolio together, they'll actually look at it, right? So she'll look at your paper, all of the art, and say, well, this is really good. But you know what? Take out plate number 7 and 8 because they don't really showcase your knowledge. Or you're saying the wrong thing there, or you're doing the wrong kind of curve. Right? Wrong kind of stroke there, or wrong kind of paint. This is not wrong and all, but she'd be able to tell you, right? Now, if you had done this instead of that, see how much better the picture looks. And you'll say, yes, that's better, right? So now take that, you know, leaf out of your portfolio. So that's the kind of thing I'll do. So you have to start building a portfolio, because computer science is an art and nobody will hire you if you don't have a portfolio. And that is why, you know, newbies many times don't get hired immediately, because people are just waiting for them to show what they have. Because, you know, all said and done, hiring is a risky process. You know, most of during the early stages, we're just trying to get hired. Okay, and so that is not the problem. The biggest problem in hiring is, you know, finding the right people. So yeah, I don't know where it's going with that. But basically, you just have to you know, make your portfolio really strong. And after that, when you get to that place, it'll be easy for hiring managers to find you if you have a good portfolio, right? And they'll contact you and say, hey, why don't you come and work for us? And that's really the place to be, isn't it? So start building a portfolio. This is your chance. Don't, you know, you have a fantastic chance. Pass it on to all the other people who are not in class today, right? This is once in a lifetime chance where you get an opportunity to start building a portfolio in a brand new field. I'm assuming that this is a brand new field for many of you, just getting into computer science. This is a fantastic opportunity to start building a portfolio from scratch, and make sure that, you know, and also you have the luxury of saying whatever you want, even stupid things, because you have someone like an art teacher who's going to look at everything you say online, in public, out there, because it's part of your public portfolio. And you have your friends out here, you have me, and your STEM tutors, Lane just joined and all, right? And Walter, we'll all keep an eye out and say, well, you know what, maybe that's not something you want your future employer to see, right? And they'll delete it. Or if there's a really fantastic post, but you made, you know, one wrong point there, you'll get a mail or a private message saying, hey, that's a great post, just change that and it'll be much stronger. All those things you'll get. So please take advantage of all those things. Yeah, well, GitHub, GitHub is okay, but I think it's definitely okay, but you also need not just GitHub, you need a way of showcasing how you interact with other intelligent people, right? GitHub, okay, you can showcase your products and you have a limited discussion. I think I haven't used GitHub in a long time. I'm pretty sure it gives you a place where you can store your assets, and also some discussion area where you can have a chat about it. I think so, right? So that's important, obviously. But where employers would look for other than that is Stack Overflow, Reddit, Facebook. Facebook not so much, because everybody assumes that it's you're going to be silly on Facebook, right? Because it's just letting off steam and being yourself and funny and not really technical and all. But people will look at Stack Overflow, Stack Exchange, Math Exchange, Reddit, and all these places. Now, you may not have a portfolio already there, but it doesn't matter. Reddit is a great place for you to showcase not your actual knowledge, but how you're able to share your knowledge and how you're able to interact with teammates, okay? 90% of my hiring decisions were in the past were influenced by how that person would interact with teammates. And I say that because, very, very early on in my career, I wasn't a good team player in the sense that I wasn't able to immediately sense what other people wanted. Sometimes I would also do something that the other person didn't want and say, well, I'll waste it. And say, well, that's not what I wanted. The specs are completely different. I can't use it. So how could you presume that's what I wanted? So you implemented that, right? So I remember, very first job, my boss called me into his office and said, this is all cool, but why did you do the thing this way? And I said, because it looks better. And he told me, no, right? It may look better to you, but these are the specs that came in, and you got to do it this way. So suppose someone says, I want a pink car. You can paint a fuchsia car and give it to them and say, oh, that's kind of shade of pink, take it. Yeah, it doesn't work. Yes, because you got to do exactly what they want. Otherwise, this product is not correct. It's not the real product, because the product is what the customer wants. You got to do it, whether you agree with it or not. And so those are things that I didn't know. And I would just arrogantly and foolhardily say, well, this is a better thing to do. This is how people should do it. And I would do it even though the customer wants it some other way. And those are bad habits, right? They're bad habits. Fortunately, I had some good bosses, okay? So because there are some bad bosses, you may get stuck under a bad boss and say that the bad manager could say, we asked for this and that person did that, right? And they wouldn't even look in your code, because, a good boss would say, well, that's not what we asked for, but they did something else. Well, let me look at it. And they'll say, well, they did something else, but still there's actually some really cool shit in there. They did some really valuable stuff, but it's not what the customer wanted. So the scope, I can go in and tell them, yeah, this is what you do. All right, you can change this and so on. But lots of managers, hiring managers, many people, they're just people managers. They don't know technology. That's why, companies where technology managers are not technical people, those companies, I don't know, they're not set up for success. And I think that is the reason why many of these early companies like Microsoft, Google, and all these succeeded big time, because they made a conscious decision saying that people in charge of technology should be technologists themselves. They need to know what the hell is going on. They can't just be people managers shuffling resources around, because a hash table or a tree can also do lookups as a vector, right, or something like that, right, for a certain use case. But why would you use a tree? Because it's logarithmic. A vector is constant time. So if you're just a manager who doesn't know the details of it, you just say what works, put them together, and they'll be happy, even if it's inefficient, right? And so when the technologist, the manager, knows what's going on, they'll be able to say, well, even though that doesn't do what's required, you're not a shitty employee, because I can look at what you did, even though it's wrong, it's got lots of really good gems in it. So I still want you in the company, but you just need to change things. No, I had some managers like that, okay? And they were able to steer me in the right direction. But I also know, unfortunately, many of my ex-classmates from school, maybe, other people that I've worked with, who landed under bad managers, who I know, where these people that I know that work for them, they're actually brilliant people, because we've worked on problems together, we've talked about complex things and all. So I'm thinking, wow, how did that guy get fired from this company, even though I know that this guy can do kick-ass stuff? And it's just because they got stuck under a bad boss and that couldn't tell the value of what they were getting, and they just matched what they were getting against specs. So, it's not exactly the same, get lost, okay? And they get fired and all. So that is why it's very important, when you go to work, eventually find a boss who actually is a technology, who knows what you're doing, who's and not just saying you need to do this so I can fit it into something else, but you need to do this, and that's why you need to do it, and this is the way you need to do it, and this is what it needs to look like, and that's the reason why it needs to look like that. And so incremental learning and portfolio building is actually all a step towards that. So keep doing, start building your portfolio right away. Okay, see, like Samir and all these other people did, fantastic. Start with data representation, right? Data representation is where computer scientists should start. Okay, you need to show a future employer that you're not only conversant with these complex data structures and how to manipulate them, but you're also completely comfortable with electrons, and how more electrons here means that's 1 and this is 0 or something like that. Okay, you need to know that you're able to think like an electron. You need to show future employers that I can solve problems just by moving an electric field in my mind, okay, without actually moving atoms or weighty matter. So and that you'll get by just showcasing and also showing, yeah, where I was going with that is that many hiring decisions are just determined by, after you establish that the person is solid, you want to make sure that when I hire that person, is that person going to be a bad apple? Because bad apples will spoil the other bad apples too in the basket. So you want to make sure that, are they able to talk to other people, right, at different levels? And the more important marker that I look for is when that person talks to someone who is obviously far more experienced, okay, they know a lot more, or they do things, and they talk to someone who's just beginning, who doesn't know, right? Now, the way to find a good employee is to look for people who will interact with both of those people in exactly the same way. Okay, exactly the same way. Whether you're hiring, whether you're talking to Albert Einstein or someone, right, or to a newbie in CS2A. Who accidentally got into CS2A when they were trying to get into a history class. Okay, so you're talking to the two of them. You got to talk with exactly the same kind of attitude and say, well, you know what? Yeah, is it interesting? Oh, what are you doing? That kind of thing. So if someone does that, bam. Okay, all I need to know is, are they technically sound? They're in the company. Okay, and that's what people are looking for. So you can round out all your skills. That's why just being good at coding is not enough. If you're good at coding, you can, you sit in your garage and develop product on your own, or with a couple of close friends, only with only whom you can get together. Yeah, maybe that'll become a unicorn and huge success, and that's great. But the chances of you succeeding are much better if you are able to work with other people productively, and I think it'll be much more fun. Okay, so please start. And I'm saying that because there's not a huge deal of conversation other than the Samir and a few other people that posted on the Blue subreddit. All of you have to just get in, and I don't know how much longer. Yeah, so you have to take advantage as long as it's available, right? Take advantage of this forum, showcase yourself. You're being given this opportunity to say, out there, you can go and put up all your best pieces, because in 3 years or 4 quarters from now, you're going to be looking for a job. So start packing up your showcase, your starting now, and don't wait until you're looking for a job when you start packing these things. Because I've seen, right, when people come looking for a job, you can Google their profiles and look for it, and you can see they have a GitHub repo, right? But when was the GitHub repo started? Like 5 days ago, right? 5 days ago, and so that doesn't cut a lot of reassurance. And you need to know that I've been doing this because it's part of me, because that's the person I want to hire, the person that is basically just living and breathing the problem sets that we want to solve. They're basically computer science mind, right? Because they're thinking about everything in that way. And so, but you can't tell an employer, I'm that way just because I've been like that for the last 1 month, right? And I'll say, well, you know what, you're like 25 years old and you've only been like that for 1 month. Well, we'll give it a couple more years and see if you're still like that, because that's the natural reaction, right? However, if you go and say, well, I want the job and I'm like that, and you can look me up on Reddit, and you can see that I've been like that for 2 years. Okay, then the manager gets a much better clue about you, saying, well, it's not that person is not like this just because they want this job. That's their natural tendency, right? They're always helpful. They're always interesting. They're always saying, cool things, finding out interesting facts. So that's the person. So Reddit, take advantage, okay? And I look at these forums, right? Even when I'm walking by the lake and all, every time I get a bip on Reddit, I usually stop and go under a tree and in the shade, and I scroll to see, well, this is interesting stuff. So I get everything you do within a minute, I get notified and I read these things. So these are, and I'm not getting much in from CS2A. CS2C, people are actually starting to, it's heat up and people are talking about interesting problems and all. 2B, I don't know, there's not many students in 2B, unfortunately. Many of them dropped because there's an easier section than my 2B. But 2A, we have a lot of students and many people are not being vocal in the forums. So please do, okay? It's not just for getting points. Because the other reason I can think of, if you're not vocal, is that you're just here for the points and the certificate at the end, not for learning. Okay, because if you're here for the learning, if you're here for the points and the certificate, you're not going to be vocal. You're going to do the bare minimum and get by, right? And that's the signal that anybody will get. Whereas if you're here for the learning, you don't care about the certificate and your grade. You're just going to say, I'm going to pick up as much as I can, because this buffet is not going to last, right? So I'm gonna go and taste as many as possible and find out what's interesting and pick up all of that. So that is the attitude that I would like to see. Okay, so please go ahead and keep the forums lively. You need to be talking and helping each other, but that is what is going to make the difference in your life later on. Now, how much you help other people with your knowledge. Right? Not helping other people, I'll carry your groceries for you. Yeah, okay, but that may not get you a job in a tech company. But if you help someone saying, well, you know what, that's a problem, but you're not able to solve it because you made an assumption about a variable that actually changed, but you couldn't notice it here, but if you test for it, you'll find it, right? So say just two-line post on Reddit. And you're not giving away code, right? You're not saying, well, this is the code that'll work. That code won't work. You just use this code that'll work. Bam. Okay. No hire right there. But if you look at the code and say, well, you know what? Or not code, there's pseudocode, and say, well, you know what? Actually, that would work, except for that one thing where you're overlooking this variable change. Okay. That's all. One line. That's enough for most hiring managers. Because that tells them that not only are you able to look at code, find out what the problem is, but you're also good enough to not brandish your victory, saying, why, you didn't know how to solve the problem, I solved the problem, here's a solution, right? I don't want that guy in my company. However, if I see someone saying, well, you know what, you didn't solve the problem, I think I would have gotten stuck in the same place because I also didn't find, I also got stuck by that variable change that I didn't notice. And after I fixed that, everything was fine. Okay. Now, if you go to our subreddit, you don't see as much well, actually, you do see even in blue, right? In blue, starting from quest 6 onwards, it gets a little bit more challenging. So if you go to blue, green, and red to the advanced quest, you'll see a lot of people who actually posted a problem. So many posts on Reddit now. In the past, I need to go and search for these. Now you can actually go any flare. You look for 10 posts, you'll find one. Okay. Where people say, this is not working. And you'll see someone else say, well, this is how you do it. No, they won't say that. They'll say, I got stuck in the same place and this is what I did, right? And saved my ass. And it's a very humble way of humility, right? It's humility is what, knowledge brings humility, I think, eventually. And you realize that nobody, even people who don't have it, they're not worse than you and you're not better than them. They're just lacking information. And that brings humility and say, well, you know what, I would have got stuck in the same place. In fact, I did get stuck in the same place. And this is what saved my ass. Okay. Or just giving hints. And so when I see that, say, well, that, I want that person in my company because I have engineers getting stuck all the time. Any company you go to, right? Software engineers are getting stuck. You go to Google at any given time, 20% of their engineers are fighting a bug they haven't solved yet, right? More than 20, I'm pretty sure. Okay. Any big company, everybody is always fighting bugs. But it's not like fighting and getting tired. It's fighting bugs in a fun way, right? Because every time you come across a bug later on, when you start enjoying it, you'll say, well, okay, that's a problem. I've got something to think about on the way back home, right? So I won't feel bored. And so you have all these interesting things that you stow away in the back of your head to think about. And many times you won't share these problems with other people, not with the way you're burdening other people, but saying, if I share that problem with Harry, he'll tell me the solution, I won't be able to solve it anymore. Right? That's exactly the feeling I used to have, because when I was out there and I was working and it's something very simple, right? So there's something called regular expressions, which is not even Right, and it's a pattern that you have to match. And sometimes some regular expressions get complex and large, and it won't work. And I remember looking at it, just 15, 20 characters on screen, looking at it for an hour, and say, it has to work. Why is it not working? Why is it not working? And next door to me, Harry is also, he is just like me, I think, and when it comes to these problems, and it's so tempting for me to go and say, hey, Harry, come and take a look at this. Why is this not matching? Okay, and I did that 4 or 5 times, and he'll come over and look. Oh wow, you know what? You got a question mark there. That's what's throwing things off. Okay, and then after he goes back, I say, bummer. Okay, why the hell did I call Harry? You know, I could have found out myself, right? Because now he just came to my office and ate my lunch and went away. Okay, so because that was really a juicy little problem that I could have solved. And I just gave it away to someone else. Not that I don't want to give it away. I'm sure he was happy to, but he has his own, right? Every engineer has their own problems. So you don't, but they don't look at it problems. They just look at it at a smorgasbord, as a smorgasbord of interesting things, and saying, well, I got all these things, right? So I can take them one at a time and solve them, right? Or I don't take them and give them away to someone else. And so I don't know. That was a little bit of an initial spiel. Hopefully we won't have too many of digressions like this in future. So if one of you can just basically take the screen, coordinate amongst yourself, everybody should get a chance, all right? Maybe we'll just go in alphabetical order, whatever. But one of you should take the screen. We'll just start with a very, very simple program. Blank screen, okay? Blank screen. Is a blank screen a valid program? You know, nothing at all. Unfortunately, it's not. Okay, in C++, a blank program is not a valid program. Maybe in Python, a blank program is a valid program. I don't know. I haven't tried it, because in Python, PHP and things like that, technically, an empty file is also a valid program, I think. Whereas C++, it has to have an entry point. It has to have an explicit entry point called main. So we'll discuss all of that. Okay. So any of you who wants to go first, okay, all you have to do is take the screen, which means that you will open up an editor of any kind, or even just open up a browser. Before you do that, make sure that you fire up your browser in private incognito mode, right? So Safari private or incognito in Chrome and things like that. It has to be private. And the reason I say that is because if it's not in private mode, when you start typing into the URL bar, or even, you know, autocomplete, or suggested bookmarks, you'll have, questing solutions sometimes, right? One time, I actually had a student with her driver license, okay, and this is getting recorded. This is getting recorded, and it's going to be on YouTube. So don't risk that kind of nasty things. Okay, because then otherwise you may not notice it, I may not notice it, and even if you notice it, you got to tell me, and I got to take it offline, and then I have to go to iMovie and cut it out and shit like that. It's a real pain. So please only start an incognito window, and then we'll just code in that incognito window. We don't need an IDE, right? For the first few classes, we don't need an IDE. We'll slowly start getting into an IDE, VS Code or Xcode or things like that, as and when we need it. And then you'll start getting a feel for why we need an IDE, why we do these things that way, right? But initially, you don't even need an IDE. Just use Notepad. You can use Notepad too. Well, I prefer just going into a browser, because Notepad doesn't have a compiler. But if you're in a browser, we can actually use an online compiler. There's like thousands and thousands of C++ compilers on the net, right? So you don't even have to have installed of something. So we'll just write program inside of your browser, and we'll get an online compiler to compile it and give us the results. Okay, we'll do that for the first couple of classes, first couple of weeks even, and get some programs going. Eventually, you will go into using an IDE for more advanced stuff. Okay, so who would like to take the screen? Essentially, all you have to do is open up a browser window and share that browser window. Okay, in Zoom, you just have to share that browser window. Great, Aldo, thank you. All right.
Got it. Mm-hmm.
Yeah, all right. Let me switch to, oh, it is on gallery view. Why am I only seeing 4 people? I got to reduce the font size a bit. The window size, the font will also go down. Now I can see more. Okay, I can see more. Your coding browser is now the size of, I don't know, that size. So I got to make out what the font is. Where are my glasses? Oh, my other glasses are over there. Okay, all right. So I'm going to try and see what you type, because it's a simple program, so I don't need to look that close. Okay, all right, Aldo. So here's what we're going to do. There is and everybody should be doing this, okay? Maybe not necessarily now, just watch what Aldo's doing, but later on, today, not tomorrow. Tomorrow, again, later on, exponentially falls off your memory, okay? It'll be much, much harder. If you do it today, it'll just be sealed in your brain, okay? All right, so the first thing we want to do is type in the URL bar online C++ compiler, okay? So which means that we're not going to install a compiler right now. Today, we're going to spare ourselves the task of installing VS Code or Xcode. It's a little bit of a pain to do these things. We're just going to code online. Okay. Oh yeah, this is an online GDB. Is it online GDB?
Yep.
Yeah, okay. You know what? That font is like super tiny. 5 pixels to write the G or something like that. Yeah, it is. I can actually read it because the inside the window, it's I can still read it inside the window. Yeah, okay. I can read main and see out and all. Okay, just Command A and delete everything. Command A and hit delete. Okay. All right, you got to an online GDB. By the way, what was on screen before? That was the answer. That was the answer to your very first blue quest. By the way, right? Because your very first blue quest is essentially that you have to print "Hello World," but you know, it's just like you got to do one minor tweak there, but you'll pass with just that code. Okay, so this is what you end up with. You go to an online compiler and gives you a blank slate. Now here, we're going to start typing our very first C++ programmer and as a program, and we're going to run it. We're going to run it also right here in the window. And the same thing later on you can do on your computer. I can show you. Once you install an IDE and a compiler, you can install, you can do exactly the same thing. We're not doing that. We're just going to do it all inside of the browser window. You know, online GDB could do a whole lot better, I think. Yeah, I don't know where they are, who started this company. They could do a whole lot better if they can just give us more real estate by getting rid of that blue bar on the left. You know, it's an ad and all, but I'm sure they have an ad at the bottom. But they could give us a lot more real estate here. Hey, how did you do that?
I think you can hide it. Like
okay, so they actually did do the right thing. Okay, all right, so, all right, cool. Hide it. Okay, great, that's fantastic. All right, so here's our very first program. What we'll do here is I'll tell you what we're going to do, and then you can tell me, well, let's do something else, and that will do that. Okay, so here's what I have in my mind. What this program is going to do initially is just say, hey guys, my name is Aldo, and I am really looking forward to getting started on coding. Okay, so he's just going to print that in two lines. You're going to print that in 2 lines with a line break after the first line. Is that okay? Now that's what I have in mind. Now, if you want to do something slightly different, not Aldo, anyone else, okay? Anyone else wants to do something slightly different, saying, well, you know what, let's make it slightly more complicated, just tell us and we'll do that, okay? In any case, we're going to take what we do now and keep modifying it, adding bells and whistles, and making it slightly more complicated, not complicated, slightly more sophisticated, and grow the program. By the end of class, we'll have actually an interesting thing, okay? So, all right, so what Aldo typed right at the top is called a comment. Do you want me to talk about these things because it's all it's out there? But if you don't want me to, let me know, and I'll just pipe down when I talk about these very simple and obvious things. That is called a comment, and a comment starts with, there's 2 ways you can start a comment. That one is called a line comment or an inline comment. A comment that starts with 2 forward slashes. If you have 2 forward slashes like that, right next to each other, it can be slash and a space and slash. That doesn't work. 2 right next to each other like that. That means it's a signal to the compiler saying, ignore everything else on this line. Yeah, that is really cool in programs, because many times in programs later on, you'll see that you're doing stuff that is not immediately obvious, right? Many algorithms, you can't tell that it's correct, but it's actually correct. Mathematically, you can prove that, right? Or you may need an extra piece of information on top of the program, which the compiler does not see, but it's required for humans to believe that this actually works. So you'll say, you may put a comment there saying, well, the following fragment is going to calculate the greatest common divisor because it does this division on line 20 or something like that. You can put a comment there. And that is for humans, not for the compiler. The compiler does not see any comments. Does that make sense? Yeah, because even though the computer is what is going to look at your compiled program and run it like trillions of times, humans are going to look at it thousands of times anyway. Because, you know, if there's a program, someone else is going to look at it and modify it. They got to be able to understand what you do. And that is the reason why comments are so important in code. And one of the gotchas that beginning programmers have to look out for is to not put too many comments in the code, because comments can litter your code. The unnecessary comments end up making your program harder to read rather than easier to read, because it's just a lot of fluff. And so you got to get into and that's a sweet spot you'll only find by experience. So as you start programming, you'll find that you put lots and lots of comments in the code, lots and lots of comments, but with experience, you'll find out which comments are not necessary, right? And there is no way I can tell you, right? I cannot tell you, get rid of the comment, that's not necessary. Yeah, that doesn't work. You have to find out by yourself which comments are necessary and which are not. And that you will only get by experience. Nobody can tell you, right? Even if someone tells you, you got to learn by experience why what that person said is correct. And so, and that is the reason when you're doing computer science is just not to read books or, or read online code written by someone else saying, oh, that's why it works. Okay. You got to write programs yourself, lots and lots. And I can tell you hundreds of thousands of lines of code, right? And you may think, oh my God, I'm never ever going to write hundreds of lines, thousands of lines. No, that is not true at all. Before you know it, you'd have written millions of lines. Millions. I'm not joking, right? So you see photos of people, right, saying, oh, this is I got a printout of all the code that I wrote for the Mars rover or Apollo 11, right? And you see photos on LinkedIn and all, right? You say there's a stack of that's all the code that I wrote, which went to Mars on a rocket. And you see so much code. But actually, that is because it was all printed out. When you're writing programs, you don't feel that it's so much. Before you know it, it'll be a million lines. And so many times, by the end of CS2A, I guarantee if you just stick with the course and do everything without your knowledge, you would have at least written tens of thousands of lines. Okay, I'm not talking about 100,000 yet. Even CS2A, by the end of CS2A, you would easily have written 10,000 lines of code minimum. Okay, without your knowing. So that is the very first line. And what is it? It says goal, print hi, I am Aldo. Okay, so that is his very first line of code in class. Maybe he's written code before, and because he put the comment and all. Okay, so the first thing we want to do is inside of your program, a blank line, and I'm going to say things like put a blank line, space, enter, and so on, just aesthetic reasons. You don't have to follow it, but it will be very useful for you to follow the aesthetic guidelines, because these aesthetic guidelines also make your programming simpler. Okay, your programming life will also be very. All right, so new line, and here we're going to start what is called entry point. C++, also Java, I think, right? Many of these higher level programming languages have a well-defined entry point, meaning that after you write your program, this program is readable by humans. Meaning it's I can read it. It says a comment, and he's going to type some English-looking characters there using English characters, right? So, for example, Aldo is going to type int space, and you're going to say main, M-A-I-N, and then open parentheses, close parentheses right there. Now put a space after that, not there, outside, outside, and then curly brace. Now the style that I follow, which you don't have to follow, is now hit return. A couple of one more. Okay, now you're going to say return 0. Okay. Semicolon. Yeah, okay, semicolon. Good. So Aldo probably already knows programming, okay, or at least in a different language. So hey, yeah, okay, these things are perfectly fine, right? So that is your minimal functioning C++ program, which means that you can compile and run it, and it will run with no problems. However, it won't do anything because you're not doing anything. You're calling main, and main says, "Okay, I'm done." You say, and says, "I've returned." So that's like that toy. I don't know if you've seen that toy. It's supposed to be a very depressing toy. It never depressed me. So it's a box, and there's a button on the box, and you have to press the button. And when you press the button, all that happens is that the box opens, and a mechanical hand comes out and switches the button off and goes back inside and shuts. Right? That's all it does. Right? So it's and people say it's a very depressing toy because it does nothing. You just press the button, it'll switch itself off again. That's all. Right? So that's what this program is. You call the program and say do something, and it just says, "Okay, I've done it." It returns. So how do you know if this is a valid program? You can go and compile it, and the way to compile it is basically hit run. Right? Yeah. There's a run button. That's it. Hit the program finish, and it exited with a code of 0, meaning that the program ran and it said no errors. How did it know there's no errors? And it knew there was no errors because Aldo said in his program return 0. Now in C++, Unix in general, when a program returns 0 to the operating system, it means there were 0 errors in my execution. Yeah, okay, that is why it returns 0. Although in C++, you'll be learning later on that 0 is actually a synonym for false, and non-zero is true, right? So here you're saying, hey, my program worked and it had no errors, but you're still returning false. You shouldn't be returning true, saying true, I ran. Yeah, it makes sense, doesn't it? But you're returning 0. And the reason for that is because historically 0, the return code of the program says how many errors, or not how many errors, what kind of error. And 0 means no errors. Okay, so now we can test that by saying change that return 0 to return 45 or some number. Okay, return 0 to 45 or something. Return something else. Return something else. Doesn't have to be 45. Yeah. Okay. Now if you run it, it'll say exit code 45. Yeah. So when later on you write programs, and that program is not allowed to print anything to the screen. There are lots of programs that you will write, many programs in which it'll do something but not print anything at all to the screen. No prints. And yet it has to signal to the operating system saying, I succeeded, I failed. And even if I failed because a file was missing. I failed because I ran out of memory. I failed because, there's many reasons. Yes. So even though a program fails, you need to have an ability to tell the invoker of your program why you failed. Yes. Think of yourself as a manager, and you give a task to your engineer saying you got to do this, and they were not able to do it, and they just came back to you and said, I didn't do it because I failed. What are you going to do? You can say, tell me why, right? So I can see if I can help you. Yes or no? That's what we're going to do, right? And so even and meaning that program that person could say, I failed, but I'm going to say print out on a billboard on 101 saying I failed in that task my manager gave me because I couldn't locate that resource, right? And you printed that up on a billboard on 101. That's one way a manager could know, right, why your task failed, but that's not a good way. You would agree? Yes, you'd agree that's not a good way to indicate the reason for failure. So like there are many programs which should not interact with the user. People think that computer programs always talk to you. That's only the tip of the iceberg, right? The bulk of computer programs that we use don't talk to us, right? What we see is only the visible part of the universe, the 0.001 of non-dark matter. That's what interacts with us. A whole lot of the program, many programs, any program you take, Google, right? That's Microsoft Windows, the UI is only the tip of the iceberg. Everything else happens outside. But so there are all these programs that need to do their jobs, but they're not allowed to talk through the UI. They can't talk to the user. So how can they signal things back and forth? How can they tell the operating system, which invokes them, I failed? And that is via this return code, right? And main is what is called the entry point, because when that is like English, right? This program is an English, right? We can read it, but the computer can't understand that because if the computer, in order to run your program, if it needs to read the English and then interpret that English, saying, oh, well, okay, what does that mean in computerese? Computerese is all ones and zeros because CPU can only understand instructions that are in bits and bytes, right? So I have to translate that to computerese and then understand what that is and execute it. You can imagine already slow, isn't it? Yes, because every time if the computer has to interpret what you wrote in English on that line and translate that into computerese and execute it, it's going to be slow. Do you agree or not? Yeah. Okay. So that is called, yeah. Someone had a question? Yeah. Thank you. So so that means that is called an interpreted language. That is the difference, right, between a compiled language and an interpreted language. Now, can someone tell me an example of an interpreted language?
Python?
Yeah, thank you. Right, Python, PHP. They're all interpreted languages because the program, at any time, the program that this computer is going to see that has to run, you can see it with your own plain eyes because it's all in ASCII and English, right? English-like. Python is English-like almost. You can read it, but that means Python is going to be slower than C++. Again, see, lots of people say, I want to learn C++ because I got Python programs and they're too slow. And by C++, I can make them faster. That person doesn't know computer science, right? That is not the right reason to learn C++, because you can have Python programs run as fast as C++ if you know what you're doing. Because in Python, any of the even interpreted languages out there, there are brilliant people who know that Python can be put to use for this extremely compute intensive task in machine learning or data engineering. However, it's going to be interpreted, it'll be slow. Therefore, I'm going to use a library in Python called NumPy, or some machine learning library. And then instead of writing my whole program in Python, when it comes to the place where I have to do this extremely number intensive task, I'll make a single call to a Python function. That Python function is written in C++, it'll work at C++ speed. Does that make sense? So when people say, I want to learn C++ because I want to make my programs faster, I'm writing in Python. Well, it's not, they're dreaming. It's not going to work that way. Okay. The only reason to do C++ is actually learn how to put together that Python hook, right? When you learn C++, you'll know, well, I use Python, but here I'm going to go into C++ and have that C++ do that. And that's how I do it. And if Python didn't provide that library, I can write the C++ library and hook it to Python yourself. So, and so you'll have that confidence. That's the reason to learn C++. So interpreted languages are very slow. And speaking of interpreted languages, Java, a lot of people think that Java is a halfway house between a compiled language. It's a compiled language like C++. The reason it's faster is because it'll basically say, is this program, I'm going to run it, this Python program, I'm going to run it like 1 billion times. It's going to be out there in production. It's going to be run like 1 billion times every minute, people around the world. So therefore, what I'm going to do is use all these C++ libraries. And so because it's being run very quickly, many times, it'll be fast. So you make that optimization. Where does it go in that? Okay. So what the system does is that when you have this program, it's going to be run many times. You'll say, right, but why do I need to keep interpreting that every single time? As a computer scientist, what I should do is if there's a problemscape, and there are lots and lots of problems, but many of these problems have overlaps. And this is a very important concept called overlapping subproblems, okay? Later on, when you do CS2B and 2C, and people are talking about dynamic programming, okay? So it's as though it's the next great thing after sliced bread. No, not really, right? Because dynamic programming, and also you go to all these interview sites, Glassdoor and LeetCode, they have this entire section on dynamic programming as though how it's a different way of looking at things. No, total nonsense, okay? It is just a computational way of doing things, saying that if you're an intelligent computer scientist, which everybody is, you're going to look at a problemscape and say, I got to solve all these problems, but all of these problems have something in common. So if you are an intelligent person, what would you do? Are you going to solve the common part every time for every one of those problems? Will you do that? Or will you solve that common part once and then use that solution for everything? What is the right thing to do? Thomas, raise your hand.
No, I said if you can make a more efficient solution and just implement one solution that you made to a lot of things, that makes more sense.
Yes, isn't it? Absolutely. Right. So if you have a lot of overlaps, you only solve everything that's overlapped, you solve once and hold on to it. That's called caching or memoizing. Keep that in memory. Once you solve something once and it's going to be repeatedly useful, okay, don't throw it away after you solve it. Hold on to it. So the next problem that requires the same solution, you don't have to resolve it, just take it from the already solved solution. So that's called caching, intelligent caching. And where are we going with that? So that is basically dynamic programming. That dynamic programming is just recognizing, looking at the problem from here. Because if you're looking at it from here, you can't see the overlaps, right? If you're looking at a picture very closely, you can't see where the things are overlapping. But you gotta be expert enough by drawing yourself back, right? Look at it from a bird's eye view out here. And beginners can't see bird's eye view because they're too close to the problem and they're down in the trenches. They can't see. Right? And the only way you can see it is to get intimately familiar with the trenches down there, okay? So that you get bored with the basic stuff. When you get bored with the basic stuff, you're going to draw yourself up and say, well, what's up here? Now, when you're up here, you can see the basic stuff at a different perspective. You can see when things are overlapping, right? It's like flat line. In flat line, you can only see lines. Now, I don't know if you've read that book, right? But when you go to the next level, you can see that it's actually a circle. It's, you look at this way, it's, you know, it's a line. But if you go up here, you can see it's a circle. You go directly to the center of the circle. Whereas here, you have to cut through the circle's circumference in order to go to the center. Yes? Whereas here, you can see that two circles are overlapping. Like a Venn diagram. You have this intersection. Whereas from here, you can't see the intersection. You just see one solid line. This is, you know, like this. So when you are able to draw yourself up and you can look at it like that, you'll see where the overlaps are. When you see the overlaps, that is where big money in computer science is, if you're after money and all that, right? Because that's what all these people are paying for. People out there are not paying, you know, engineers to just come and solve problems, okay? Because in solving problems, it's a straightforward way. There's all these calculi you can use, and there's more and more toolkits coming up and frameworks, and yeah, and pretty soon AI will be able to solve all the basic problems, right? You only need creativity to solve the next level problems, and so solving problems by itself is not all that valuable in terms of commanding, you know, stuff that you want. What is valuable is not just solving the problem you have, but looking at it and seeing what are all the common parts, what are the overlapping subproblems, what is it that you can do without having to keep doing over and over again and just keep reusing. That is a skill that I found in my experience is the hardest for beginners to get, okay? Newbies, fresh hires, take them a long time to get to marinate in the company juice, right? They got to get to know a lot of stuff before they're able to spot, just being able to spot. Even though you may be an expert in the field, that's the other thing, right? You may hire an expert in the field into a new job. Even they will not be able to solve the overlapping, you know, they won't be able to tell, but they'll be, you know, usually seasoned enough and clever enough to say, well, I can see the overlaps, but there are overlaps there, give me some time. So because they'll know, I need 2 months to get to know everything so I can see the overlaps. But a beginner will not be able to see the overlaps and say, there's no overlaps, I can't do anything, I can't make a difference in this company, I'm doomed. Right? So they won't give themselves the 2 months. Beginners don't give themselves time. Experts always give themselves time. Okay? Beginners are under the illusion. Beginners and newbies are always under an illusion that they don't have time. They got to do everything today. Okay? But with seasoning and time, better engineers, better software engineers, managers, better employees will figure out that all they need is just time and never to panic. And when they find a problem that they can't solve, they don't say, wow, I don't know how to do it. They just say, I need more time. Okay, I need more time. And the time, even though you're not thinking about the problem, just looking at all the superficial things, you'll automatically find there's so many things that are overlapping. Bam, bam, overlaps. So all I need to do is solve all the overlaps and hold them once. So the rest of it, I don't have to solve, you know, everything multiple times. So that way, that is dynamic programming. Okay, it's overlapping subproblems. You'll come across this term many times. Finding overlapping subproblems, solving them once, and holding on to the result. That is basically dynamic programming. You know, and you can find lots of problems in leak code that do these things. Well, we're going with that. So yeah, all right. So Java is like this middle ground where it says, you know, if you want to translate all the way from English into computerese and then execute it, I agree it's slow, right? However, if we translate all the way to computerese, like C++ does, C++ and all other, they're called compiled languages, saying you write it in English, and then once you're happy with how it looks in English, I'll translate it into computerese in bits and bytes, and after that, you won't be able to read the program. So after we compile this program, we won't be able to read it, but the computer will be able to read it. So the computer will, so it's called compiled directly into machine code. That means from that point onwards, humans can read it, but a computer can read it really fast. Bam, 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 like that, because it's been already translated into the very, very specific language for my Macintosh. Well, in this case, it's not my Macintosh, although it's running this program on some remote server. I don't know where online GDB is hosted. You know, you can just find out, but maybe it's somewhere in Italy or some other country, right? Zambia or something like that. So out there in Zambia, there's a computer. And which server, okay, that is running this program. And so yeah, so on that computer, which may be a completely different architecture, we don't know. You can't tell, right? You can't tell from here what kind of computer that is. That may be a Macintosh in someone's home, or that may be a Windows PC, or it may be an ARM chip on a phone, Who knows what that computer is? On your own computer, you know, it's a Mac. You can run things, right? Or a PC. But that one, nobody knows. It's out there. So that means that once your program has been taken and translated into that computer's language, my computer can't read it anymore, because my computer only understands Windows, Intel CPU instructions. Or, you know, also your computer may only understand ARM CPU or Apple CPU instructions. They're all different, right? Because of competition and crazy, you know, things, they all use different languages. There's no standards. You know, this is what was it, a Strustrip or something else? Tannenbaum. This is the data communications guy. When I was, you know, learning, when I was a student, I read this very interesting statement by him in my data communications textbook. And it says, standards are so cool because there are so many standards, okay? There's so many to choose from. That's what he said. And that is actually a tongue-in-cheek remark, isn't it? Because the whole point of a standard is that you don't have so many choices. You only have one choice, and you can go for that, and it'll work on everything. That's a standard. A standard meaning it works on everything. But Tannenbaum was saying, you know, standards are really cool because so many standards. You can choose from so many standards. It defeats the whole purpose of standards. Anyway, because there are so many different standards in CPU instructions, you have Intel CPU, Apple CPU, all these different things. And so once it's been completely translated by the C++ compiler for a particular architecture, it cannot be interpreted, it cannot be run anymore by another architecture. So once you go the C++ route and write the program, turn that into a particular architecture, that's it. It's frozen for that kind of architecture. It'll only run on Macs from that point onwards. It won't run on Windows machines. However, Java said, okay, well, you know what? It's really fast. I grant C++ that, that if you write in C++, it's going to be really fast because it doesn't have to go through the translation part. However, it's now locked, right? I can't run that program on other machines. So Java said, let's go the middle way and say, we're going to write a program in a language which can read in English. However, we'll turn that into some halfway house, which is not really Intel or Apple, or we're not going to go all the way down, but we'll go one step away from there, saying we'll take that program, which is going to have a lot of comments and lots of useless fluff that the programmer have put in. We'll strip all that out and condense that program into byte-wise instructions, which can be translated almost one for one in constant time, right, into CPU instructions on any architecture. So Java went that route and said, write it in your English-like language. I'll translate that into bytecode in Java. Now that bytecode can be translated by another Java program. That Java program, I can write a specific program for Intel, another Java program for Apple. So that translating part is called the Java runtime environment. Okay, so that runtime environment plays the part of the intermediary between the CPU and the semi-compiled Java program. So Java is slightly faster than Python and all, but still it has to go through that step. So it's intermediate. It's called a bytecode interpreted language. Okay, it is still an interpreted language. Java is not a compiled language. People will think I'm compiling Java, but no, it's not going all the way to machine code. It's going to some intermediate. It's an intermediate bytecode language, okay? Bytecode interpreted language. So Java is also slow in that sense. But again, just like in Python, even in Java, I know, right? We can write in a previous company. So in my team, we had to write these big projects in Java, but there were, places where compute number crunching was very important. It had to do it fast. So likewise, just like in Python, there are libraries in Java that do heavy duty number crunching, not written in Java, okay? Written in C++, imported into Java with just a hook available in Java. So in Java, you make one function call, and that goes into a C++ library that just does everything in C++, okay? So any language you choose, PHP, Java, doesn't make any difference these days, okay? The important thing, so that's why I don't believe in, people say, I want to learn C++ to go and do faster programs. That is total nonsense. And in fact, you should disabuse people of that notion. When people say, I'm learning C++ because it's faster, why is it faster? And I say, oh, because I want to do this? No, then you can tell them, oh, you can use a C++ library in Python. You can do the same thing too. So that's the way a conversation should proceed. And so Java is also slow, but that's not the reason you should learn C++. You learn C++ because you want to get to the very nuts and bolts of what's going on, and also be able to craft things in a higher level language like Python You want to be able to craft things without having to go to Google or Stack Overflow and looking up, right? I want to do this, transformation to this data structure. What's out there? And you'll find like 10 or 15 libraries, okay, on Stack Overflow. And then that's not the end of the story, right? Even if you find 10 or 15 libraries to do what you want, you have to go to GitHub, download the code, and then you got to do proper vetting of the code. Because you can't just download some shitty code from somewhere and integrate it into your program, right? And the customer will basically stop using your product if something crashes. Yes? Because when you download something off the net, you got to check it first. You got to look at all the comments on Stack Overflow, right? Look at all the top 50 comments with high votes. And look at low votes, right? The negative votes, and say, why are these people downloading this package? What's wrong with it? And you'll see, right? Oh, and someone will say, well, you know what? In this case, it throws an out of bounds exception, right? And it'll crash your computer. But it only happens once in a million times or something like that. So people are using it, but that person made that comment and downvoted the package. How do you find these things out, right? It takes a lot of time. And I can tell you right now, right? I'll save you that bitter experience. Maybe you need to go through the experience, right? The bitter experience of finding a package. Many times you'll find, over 50% of the time, you go online looking for a package, and then you spend a lot of time looking at all the comments and looking at the source code on GitHub and seeing if they're doing the right things, okay? And you'll come to the conclusion one day saying, you know what? Why the hell am I wasting time doing this? I could just write this in C++ myself. That would take me 2 hours. Now I spent 10 hours going through shitty code written by some other people. Not always shitty code, right? And many times you can find some good libraries that trusted, but many times, other times you'll find that you download code, you got to do a lot of vetting and examination. Better just write it on your own, right? That is something I did with also with questing, right? When I did build the questing system, there were lots of things that I needed to do. And there were libraries out there, even JavaScript and so on, I need to download. And then I used that for, a couple of weeks even. I was, using those libraries, and it was fail in mysterious ways. And then I have to go looking into the source code of that library and say, well, that is why it fails. That person wasn't careful enough to do this, right? And then eventually I came to the conclusion, well, what I need to do in questing is actually very simple. I'm not doing a lot of sophisticated stuff, right? Even UI and JavaScript, it's all very simple stuff. Why the hell am I using these libraries? I only use a bare minimum libraries, and everything else I just write myself, right? And that way I actually found I could do this much faster. So the questing system was built under a month, right? Just by one person. And if I'd been using other libraries, I'd be beholden to so many things, and things will be failing. I need to ask someone else to fix it. Pain, okay? So it gives you real power to go all the way to the bottom. That's the reason why you use a compile language, and you're knowing how to do these things. Okay, so now this basically exists, and is everybody clear on what this program is? It's the entry point. Yeah, okay. This is the entry point was what I started talking about. This main program is this program. After you write it, is translated into computer ace, as I said, and is stored on disk. It's not immediately run. It is stored on disk somewhere. It's on your computer, on your hard disk. On a hard disk, you can't run a program. It'll take ages to run a program if you're actually running on magnetic media, right? So the program, before it's run, it needs to be all the instructions that are stored on your disk need to be taken, put into RAM, your memory, 8 gigabytes or whatever it is. It needs to be put there, and then your operating system will be given a signal, right? The operating system will signal the CPU, right? For saying, well, I took that program from disk, I put it in memory at location 4700, 315, right? Now I'm going to set your pointer, instruction pointer inside of the CPU. Inside of the CPU, there's an instruction pointer. Those of you who are doing architecture, probably recognize what I'm saying, right? There's an instruction pointer that says, what is the next instruction I have to execute? Right? I'm going to go, right, 43,714. I put that value there. Okay. And then I tell the signal to the CPU saying, okay, CPU, now you can start executing. Your first instruction is at 43,714. Okay. From that point onwards, CPU takes over. So it goes to location 43,714, finds the instruction there, executes it. Okay. Takes the next instruction after that, executes that. Bam, 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 bam. That's all it's going to do until it executes a special instruction in that string, right? In the stream of instructions that says you're done, exit. Okay, that return 45. Until it gets to that exit instruction, it's going to do it one step at a time, one instruction at a time. That's what's going on. Now, how does the CPU know where to start? How does the operating system know, dear CPU, you have to start at instruction the instruction in memory that is at byte number 43,714. Right? How does it know that's where to start? And the agreement between C++ programmers and the operating system and the compiler mediating things is that in your program, you will have a special function, a special method called main. Okay, and this is the same in Java too. So there is you write a method called main, and inside of your main, you can put, that is your entry point. So when the program starts up, the first instruction instead of main, that is going to be your entry point. So that is called the entry point of the program. Okay, so that's why we have main. And so the instructions are loaded, and main is where everything starts executing. Okay, so that's the entire cycle of the program. You write it, the compiler takes it, turns it into machine code, and then stores it on disk. And the operating system, when you want to run the program, will take the image on disk, put it in memory, and then find out where main is starting in memory, okay, and take that value of the memory address and put it inside the CPU, saying, here's the instruction counter or instruction pointer. Now you can start. All of that dance happens every single time any program is run. Does that make sense? Was this useful at all? Yeah, because this is what we're going to do for the rest of this class. We're going to write lots and lots of programs, and this is exactly what's going to happen. Now, if everybody's happy with that, we'll go on with the next stage of embellishing this program, writing more things in there. But I want to get some kind of a signal from you guys saying, we're all right. Will, Aldo obviously is typing. Is everybody raise your hand if you're okay with this? Okay, everybody raise your hand, and I will. Okay, good. All right. So I'm going to assume that there are no doubts or questions at this point. Yes, can we move forward? Okay. All right. So now let's say we want to print something on top, like we said. Okay. So we want to say, whatever that is. Hi, I'm Aldo, and so on and so forth. And it's got to be in 2 lines. Okay. So there is an operator, but it's not an operator. Okay. It is an object. Okay. There are things. We'll just call it a thing. We haven't talked about objects. Okay. There's something called. There are things inside of pre-manufactured things in C++ that are given to you in a library. Anytime you use any compiler, it comes with a stock set of certain basic functions that are already available to you, right? One of those functions gives you the ability to talk to the user, meaning you can send stuff to the whatever is displayed on screen, and you can read stuff from the keyboard. Those 2 are given to you right off, off the bat. When you start it up, it's available. Now, the objects that make that possible for you, things that make that possible for you are 2 things, right? One of them is called the console output thing, right? A console output object, right? What would you, if you wanted to give a name to that object that sends out to the console, what would you call it, right? Suppose you had to name it. Suppose you had to name that thing that takes what you give it and sends it to the console, right? It goes to the console out. What would you call it? Yeah, okay, David said C out. Okay, well, he probably knows because otherwise you're a console out or something. But so the name chosen by C++ designers was C out. All right. Yeah. So hey, Cruz. Oh, okay. All right. Yeah. Okay. So he has to go. That's fine. But mostly just don't use a chat. Okay, chat messages you send just flash on my screen and go away, and then I have to open up the chat thing, and it takes up a real estate, and I can't. Okay? Just be vocal, okay? And I shouldn't be the only one talking. If I'm the only one talking for the entire 2 hours, I can throw his horse at the end of the class, and you should all be talking. Give me an opportunity to not talk, okay? All right. So C out is the thing that has been already created for you by C++ engineers, designers, right? It's there in the library. What that says is that C out is an object that is given to you, which knows that anything that comes into it needs to go to the screen. Okay, and the way you send stuff to C out is using what is called the left shift operator. All of these things you'll learn later on. The left shift operator is what Aldo just typed in. It is 2 less than signs immediately after each other. You can't have a space between them, just like the comment. If you have two less than, again, right? These, I recognize that the two comments and this left shift, they don't look like English. Very few things like that, okay? Maybe there's 15 or 20. That's all, right? Imagine when you're learning music there, you got to remember hundreds of little things. But here in C++, there's only 15 or 16 different things like this thing, right? So easily, very easily, you can remember these things and not be thrown away. Lots of people look at those things and say, wow, it's a different language. I can't even make sense of it. No, okay? It's very few things like that. So that, and I'll point them out, like ternary operator and things like that. Okay, so that is a left shift operator, and it is used for shifting bits later on. In 2B, you'll encounter that, but it's a left shift operator. Now, instead, what we're going to do is in C++ for the cout object, we're going to left shift something into cout. Okay, so let's left shift. Hi, I'm Aldo. Right, hi, I'm Aldo. And then put a period there, and then put a semicolon at the end of the statement. Yeah, okay. Now, if Aldo runs it, he will see the line. Okay. All right. We're using the cout operator, the object, but we haven't told the compiler where to find it or what it's going to do. Now, C++ also gives us not only all these cool objects that we can use right off the shelf like this, but it also gives you a little file that tells the compiler, essentially, not us, tells the compiler that this is the nature of the object. This is the nature of this object. I'm going to give you 5,000 objects, simple objects, and the compiler, don't complain when you see these objects, because that is an output operator. This is how it behaves. This is an input operator. The object, this is how it behaves. So there's a list of all of these in a file stored somewhere. All we need to do is tell the compiler, don't be spooked and throw in the towel. I'm using something which you know about already. If you don't, look at this file, and this file will tell you all about it, right? So go right to the top, right there. Yeah, exactly. Thank you. Yeah, and say hash include. Okay, hash include. And no, yeah, there we go. Hash include, and then put an left angle sign, left, yeah, right. Inside, you're going to say IO stream. All right, so that again is one of the other things. I said 16 things you have to remember. Okay, that's number 2. Right, number 3, comment and this and this. That particular construct there that says to the compiler, that file, there is a file in the system somewhere hidden. All right, I will show you where the file is if you want later on, but it's there. It's just a text file, right? So it tells the compiler there's a file called IO stream. Look in that file. That file will tell you everything you need to know about this thing called standard cout. std:/cout. Okay, from that point onwards, the compiler will not complain when it says cout. Okay, now if you compile and run it, it'll actually say hi, I'm Aldo. However, it will not have a new line. Oh wow, it's got a new line. It's not supposed to have a new line. Right, now go to line number 7, triple click, copy and paste it under that. Yeah, copy that and paste. Command C, triple click. Yeah. All right, okay. And indent properly. Now change that second line, hi, I'm Aldo, to what you had up there. I'm excited to be in this class. Okay. Oh, I said this class. All right. So this class. Okay. All right. Cool. Now don't run it yet. If he runs it now, you would expect to see 2 lines like Jesse's got in the program, right? The first line says, hi, I'm Aldo. The second line says, I'm excited to be in this class. Now, this is a stylistic issue that, I think programmers are not being taught in school, in class, but they ought to be taught. One of the things as you write programs is that when you write programs that are going to interact with the user, the way your output looks in your program should be exactly the same way the output is going to look to the user. Meaning that if you run it now, what the user sees will be different from what you have. Run it now. There you see that? We have 2 lines up there, but what the user sees is completely different. Now, good programmers, what they'll do is they will make that look the same as this, meaning they want a new line. They want wow, the power just went off. Oh, hang on. Can you guys hear me? 1 sec. Okay. Oh, wow, wow, wow. Okay. I'm gonna.